In the previous video, we saw how to solve equation involving equalities of expressions with modulus. But in this video, we'll see how to solve inequalities involving modulus. For example, imagine I have this example to solve. And I ask you to solve mod 4x plus 3 is more or is bigger than mod of 2x minus 1. So there are different ways to solve this kind of inequalities, and I will show you 3 ways to solve this. Well, the first way is just graphically. I just need to draw the 2 lines or the 2 graphs for the expression y is equal to mod 4x plus 3 and y is equal to 2x minus 1 on the same grid. So drawing it, I will have 2 graphs like that, one green and one blue. And since I would like to get 4x plus 3, I need to solve 4x plus 3 is more than 2x minus 1 in modulus. It means I need to get the regions where the graph for mod 4x plus 3 is on top or is above of the graph for mod 2x minus 1. So I see here that the 2 graphs meet at the 2 points A and B. And at A, I have the equality that for negative 4x plus 3, because on the region where I'm doing the reflection of the graph y 4x plus 3 in the x-axis. So this is why the expression of the function is minus 4x plus 3, and the same thing happened for the other function, 2x minus 1. So this is a reflection of the line here, right? So at A, I have the equality of the 2 graphs there, so I can solve that. I can get the value, the exact value of A, right? So doing that, I will get that x is equal to negative 2. And the same thing for B, I will do it. So I know that for this part, the expression of the graph is 4x. The expression for the blue graph is 4x plus 3, and the expression for the green graph is negative between brackets 2x minus 1. So solving that, I will get that x is equal to negative 1 over 3. Right, so I have the 2 parts here. I have the 2 values, 2 critical values for x. Now, how will I solve this graphically? Well, I just need to pick the parts where the blue lines or the blue graph is above the green lines. So as I can see here, if I take whatever value x that is less than negative 2, the blue line is above the green line. And the same happens here. If I will take any value that is more than negative 1 over 3, the blue graph is above the green graph. So this is why I can say that the solution should be any value that is less than negative 2 or any value that is more than negative 1 over 3. So this is how I solve it graphically, just looking at the 2 graphs and deciding what is the value of the meeting points. Well, I can solve that algebraically like I did here. But to decide what is the solution, I just need to see the graph and pick the parts where the first graph is above the second graph. Well, this is a way. Let's choose another way. The second way is similar to what we did when solving inequalities. But here, it will involve solving quadratic inequalities. Well, we will square both sides, okay? So if I have mod 4x plus 3 is more than mod 2x minus 1, I just take the squares of both sides. So I will write it like that. And since it's a positive quantity here, I may replace the straight lines here by brackets. Okay, it doesn't change anything. And then I need to expand the brackets, like that. So I'm just choosing the expression a plus b squared, so it will be a squared plus 2ab plus b squared. Well, I did that in the two parts. Well, here I use it a minus b squared, okay. Right, and after writing it like that, I just need to rearrange it and collect all the like terms. So I send 4x squared to the other side with negative sign. So 16x squared minus 4x squared is equal to 12x squared. And if I send negative 4x to this side, well, it will go with a positive sign. So I will have a 24 x plus 4x is equal to 28x exactly, and then I will send 1 to the other side with a negative sign. So 9 minus 1 is equal to 8 exactly. Well, if I will focus a little bit, I will see that all the coefficients are multiple of 4. So this is why I put 4 as a factor. And yeah, I can simplify by that 4. I will divide both sides by 4. So simplifying it like that, I will get 3x squared plus 7x plus 2 is more than 0. And I can factorize this one in this way, right? Well, we still have to factorize expressions like that. So factorizing it like that will give me that this expression, this quadratic expression, I can write it like 3x plus 1 times between brackets x plus 2, which is more than 0. So I have a quadratic expression here, and I would like to get the regions where it's positive. So a way to do this is I just draw the quadratic expression or the quadratic function, just a quick sketch, okay, on a graph, and I see where it's positive. So we can see that negative 2 and negative 1 over 3 are the solutions. So for these two values, the expression here, the quadratic expression, is equal to 0. But between the two values, the expression is, or the quadratic function is negative. As you can see here, it goes down. It goes less than 0. And for any value that is less than negative 2 or is more than negative 1 over 3, this expression is positive, right? Or the graph is positive. It shows that it's above 0. Well, just using the graph like that, I can deduce that the inequality is satisfied if x is less than negative 2 or x is more than negative 1 over 3. Right, let's see another example here, or another way. And another way is based on removing the modulus signs. Right, well, how will we remove that? Well, the first step is I need to find where the graphs intersect. It means I need to solve it as it's like an equality, not an inequality. Right? It's the critical points, let's say. So I just need to solve this equality here. And doing that, I will get that the two solutions are x is equal to negative 2 and x is equal to negative 1 over 3. So this is the first step. Solve the equality and pretend that is an equality, not an inequality, and get the two critical values. So first step is done. Second step, I just need to take values in different regions of between the two solutions. Well, I know that the two solutions are negative 2 and negative 1 over 3. So I have three regions here. The region that x is less than negative 2, the region where x is between negative 2 and negative 1 over 3, and the region for x is more than negative 1 over 3. So what will I do? I will start by the first region, region 1. So I will pick a value that is less than negative 2, and I will substitute in the expression and see if the inequality is satisfied. So I'm picking, for example, x is equal to negative 3. Negative 3 is less than negative 2. And I will substitute in the expression. So I will take the value of x is equal to negative 3 here. So 4 times negative 3 plus 3. So 4 times -3 is -12, plus 3 is -9, and mod -9 is equal to 9. So this is the first side of the inequality. The second one, 2x minus 1, the mode of 2x minus 1. Substitute x by -3, so 2 times -3 minus 1. So -6 minus 1 is equal to mode -7, which is equal to 7. Well, the region we have, in this region, we have that 4x plus 3 is more than 2x minus 1, since 9 is more than 7, so the inequality is satisfied. And I can deduce that this region is part of the solution, so I need to keep that part, right? So the region where x is less than -2 is one region of the solution. Let's pick the second region. Second region, I need to pick a value between -2 and -1/3. Well, the simple value is -1, right? And I will do the same thing, substitute in the expressions. So substitute in the first expression, I got that it's equal to 1, and substitute in the second region, I got it 3. Well, 1 is not more than 3, so this is why this region is not a good region for me. It's not, it doesn't, the values that are in this region doesn't satisfy the inequality for me. So it's not part of the solution, so I don't pick this part. I will do the same thing for region 3. So I will pick a value that is more than -1/3. For example, 0. 0 is a nice value. And I will substitute in both expressions. So when x is equal to 0, 4x plus 3, the mode of 4x minus plus 3 is equal to 3. And the mode for 2x minus 1, when x is equal to 0, is equal to 1. Well, 3 is more than 1. So I can say that this is part of the solutions. This region is, I need to keep this region for a solution. So I can deduce finally that the solutions for this inequality are in the two regions. Okay, so for x is less than -2, or x is more than -1/3, and I need to keep these two regions. Okay, because any values in one of these two regions satisfy the inequality. Right. Well, I think you are ready to work on exercises now. Please send your questions, and we will have our Zoom session on Friday. So let me know whenever you need help with exercises. Thanks for watching. Have a good day. Bye-bye.